recently the types of angles we've been looking at. What's that? What type of angle is that? What was that called? Nope, that one's not inscribed. This is from section 1. Actually, maybe it's section 2. I can't remember. Central angle. That's a central angle. What is the relationship between a central angle and its arc? They're exactly the same. Some of you are struggle remembering that. What that's called. You're going to have to know that. What type of angle is this? This is an inscribed angle. What is the relationship between this angle and the arc? The angle's half the arc. Okay? Meaning the arc is double the angle. Okay? So just keep that in mind. We also had, what would you know if a quadrilateral was inscribed inside a circle? Opposite angles are supplementary. So those two add to 180, and those two add to 180, correct? Okay. What do you know if you have a diameter and then a triangle? It's a right triangle. Okay, as long as it's inscribed, correct? Okay. So just keep those things in mind. Just a quick review from last week. Okay. The first thing we have here is a theorem. We have 3 theorems today, none of which actually have a name. So, if you want to put the names that I put up here on there, that's fine. If you don't and you just want to put the number, that's fine as well, because we're not really using the name anymore. But what the name is going to do for you is it's going to help you understand when to use the theorem, because it's going to tell you what the diagram looks like. Okay? So we named this one tangent and chord intersect. Now, everybody knows what a tangent is, right? Touches the circle just at one point, and a chord is on the inside of a circle, and the endpoints are on the circle, right? So there's really only one possibility for where they intersect, and that is right on the circle. Yeah, Travis? The tangent is also perpendicular to the radius. Good. Okay. Our theorem says if a tangent and a chord intersect, then the measure of each angle formed is 1/2 its intercepted arc. If a tangent and a chord intersect, then the measure of each angle formed is 1/2 of its intercepted arc. Okay, so when I put this diagram up here, that is a tangent, that is a, so what? It's a chord. I'm looking at angles 1 and angle 2. So I know that each angle, so let's start with angle 1, is, according to my theorem, the angle is 1/2 of what for angle 1? What's the intercepted arc? I'm going to say AB, but yes. Hey, does everybody see how this arc is the intercepted arc of angle 1? Yes? Okay. Now, one way that I like to think of that, I know that in an inscribed angle, the angle is also half the arc, right? If I get rid of this, isn't that basically an inscribed angle? Isn't the angle on the circle? Okay, the only difference is one side goes outside the circle and one stays inside. Usually with an inscribed angle, they're both inside. Okay, but it's still doing the same thing. Okay, so just keep that in mind. If it's on the circle, it's half the arc. So Taylor Arnett, what would you say about angle 2? ACB, good. Notice she used 3 letters there. Why? I meant B. I think she said B. Why did she use 3 letters? Because it is a major arc. Okay, that is a major arc. Yes, Royal. Because if it's intersecting a tangent, because that's the angle being formed, it's talking about the angle from here to there. That angle. Not the angle, this isn't an angle from here to here. That's not an angle, because this is curved. Does that make sense? So it's talking about from the angle, because an angle is 2 rays. That's from chapter 1. And it's talking about that whole angle. Does that make more sense? Alright, so I'm going to not necessarily write these examples down, but let's go ahead and say that arc AB was 100 degrees. What is the measure of angle 1? 50 degrees. Okay, so if this arc is 100, the angle is half of that, which is 50. Okay, hopefully everybody knows that, not just Seth. Okay. Could I then, if I knew this was 50 degrees, should I be able to find angle 2? Why, McKenna? Or how? Right. So even if I thought of it, without this circle, those 2 angles form a linear pair, right? Okay, so what's this angle? 130. Well, if that's 130, what's arc ACB? 260. Good. Okay. Alright, the example I really wanted to do with this is, if I can find it, there it is. This is 3x degrees. Bless you. And this one is 4x plus 50 degrees. Not quite as easy just to do in your head, is it? When they start throwing variables at you, it gets quite a bit more difficult. Tamaya, how would you set this up to solve for x? Well, what do you know about the angle? It's what of the arc? Half. So set that up. The angle, 3x, is half, good, 4x plus 50. Okay, so I have it set up properly, right? Okay, so I have 3x equals half of 4x plus 50. What is the... There's multiple ways to start solving this now. Okay, Travis, how would you do it? So basically what they did is they divided by a half. Which you end up, if you divide by a half, you actually multiply by the reciprocal, right? Okay, what's another way to do it? Distributive property. Okay, half of 4 is 2x, half of 50 is 25. Now that's great. That's going to be harder if these weren't both even numbers, though, because then you'd have fractions. Okay, so you want to try to avoid fractions. This time it really doesn't matter. Okay, personally, this time if I saw even numbers, I'd have distributed. Okay, to make smaller numbers. If I multiply by 2, I'm actually making things bigger. Does it matter? No. Okay, it doesn't matter. So however you want to do it, just remember sometimes if you distribute, it might give you fractions. So what do I do here? Subtract 2x, and I get x equals 25. If you're just solving a variable, it's just 25. Now, there was a handful of us on our last assignment, 10.3. The directions said, find the measure of angles x, y, and z. Actually, it was A, B, C, and D is what it was. Find the measures of angles A, B, C, and D. This is what the answer was I got from a lot of people. What do you suppose happened when I got to that problem? That's wrong. Now, maybe that is what x and y equal. Okay, so maybe you did your math right. But did you give the answers it asked for? No. So you have to be careful. Make sure you understand what it is asking for. Just because you look at a problem and it has an x and a y in it, doesn't mean that's what they want you to solve for. Okay? So here we solved for x. What if they would have wanted us to find the angle measure? What would you do with that? You would plug it in and you would get 75. Okay, so again, it all depends on what they're asking for. Just be aware of that. Okay? Look and read the directions and figure out what they're asking for exactly. Questions so far? Again, it's not super confusing. There's just going to be a decent amount of notes. Okay, before we go on, I just want to make sure everybody's on the same page with this. Where do those two things intersect at? Inside the circle. Now where? On the circle. Outside the circle. Okay, just so everybody's on the same page with that. Because we're going to use that terminology on this next couple theorems. This theorem we called chords intersect in a circle. Again, you don't have to name them if you don't want to. That's up to you. Just kind of tells you what the diagram's going to look like, though. Before I ever write anything, you're going to know that the diagram's going to have chords intersecting in a circle, right? Okay. Alright, this theorem is a little bit longer. It's the longest one we have today. If two chords intersect in the interior of a circle, then the measure of each angle is the sum of the intercepted arcs, or actually the theorem says of the arcs intercepted by the angle and its vertical angle. Today? Yeah.
Okay, thank you.
If two chords intersect in the interior of a circle, then the measure of each angle is the sum of the arcs intercepted by the angle and its vertical angles. That's a lot of stuff, right? Okay, so let's pick out the important stuff. Okay, the measure of the angle is the sum, which means you're doing what? You're doing addition. Sorry. It is 1/2 the sum. That's very important. Sorry about that. The angle is 1/2 the sum of the arcs intercepted. I would say those are the 6 most important words in there. The angle is 1/2 the sum of the intercepted arcs. So in our diagram, we have our two chords. Okay. And let's say we have angles 1 and angle 2. Now, do I have to solve for angle 1 and angle 3 using this equation? Yeah, you don't have to because they're vertical angles. If you know 1, the other's exactly the same, right? Same thing with 2 and 4, correct? Okay. And actually, if you found 1, you have a linear pair and you could find 2 also, right? Okay, so you actually should only have to do this once if you were trying to find all the angles. Okay? But just be aware of your equation. So, our angle is, we'll do angle 1, is 1/2 the sum of which two arcs? So which arc is intercepted by angle 1? BC, so it's half of BC plus the intercepted arc of the vertical angle, which is AD. Okay, so it's going to be half of its arc and the arc of the vertical angle. So then Amanda, set up the equation for us for angle 2, please. Good. And in these equations, does it matter if I switch these? No, because you're adding them together, right? If I was subtracting, would it matter? Yes. Okay, but addition is commutative. You can do it in any order. Okay, so it doesn't matter which order there. Okay. questions on that one? We're going to do one more theorem and then we'll go back and do examples. Okay, last theorem. This one, the name was longer. We called it tangents and secants intersect outside a circle. Okay, so I'm going to shorten this up a little bit. This works for two tangents, two secants, or a tangent and a secant. Okay, so any combination you can come up with here, this works for. So I'm just going to say if tangents and secants intersect in the exterior of a circle, then the angle formed is 1/2 the difference of the intercepted arcs. If tangents and secants intersect in the exterior of a circle, then the angle formed is 1/2 the difference of the intercepted arcs. What would some important words out of this one be? Angle is 1/2 the difference of the intercepted arcs, right? What does the word difference mean? We're subtracting. Okay, so you could have up to 3 diagrams for this theorem. The first one would be a tangent and a secant. Okay, so angle 1's here. I have A, B, and C. Angle 1 is 1/2 the difference, so I know I'm subtracting, of my arcs. Now, if I'm subtracting, what one has to go first? What's that, Royal? The bigger arc. Not necessarily a major arc, but the bigger one, right? Because if I take the small one minus the big one, I get negative. Can I have a negative angle? No, that doesn't make any sense. So I always want the big arc. So in this case, it would be BC minus AB is the other intercepted one. Okay. That's one scenario. Again, that's with a tangent and a secant. You also might have two tangents. In this case, angle 2 is half of... Why did you use 3 letters there? Because it looks to be a major arc. So DFE, minus DE. They're all going to be the same concept, right? Okay, and then the last one would be if you had two secants. So we'll call this angle 3, G, H, I, and J. And in this case, angle 3 would equal half of JI minus GH. Good. Okay, same concept on all 3 of those diagrams, right? It's half of the big arc minus the small arc. Okay, and the way we talked about in the last couple classes to remember these, if you're intersecting outside the circle, you subtract. If you're intercepting inside the circle, you add. And then from there, they're both half, right? Okay, so you intersect in the circle, you add. You intercept outside the circle, you subtract. Wasting space here. Okay. So I got 3 examples here for us real quick. First one's going to be pretty short and simple. I have 2 chords intersecting. So that means I'm going to do what? They're intersecting in the circle, so I'm going to add. They tell me this is 140 degrees, and this other one, that's actually going to be backwards, 150 degrees. They want to know what is the value of x. I do want to set this equation up. I know that we might not have to, but I want to set it up because you will have to be able to when they start throwing more variables at you. So Taylor Hart, can you set this equation up for us, please? X equals 1/2 150, careful, plus 140. 150 plus 140 is? What's half of 290? 145. Okay. Again, may not have needed an equation, but if I would have done this, probably can't do that one in your head, can you? Okay. So just be aware, you do need to know how to set up your equations. Okay. 2 more problems here real quick. I have circle, I have a secant and a tangent. My angle here is 72 degrees, this is x degrees, and this is 200 degrees. They want us to solve for x. This one's a little bit harder. We do know that this angle is what? Well, but it's also half of 200 minus x. Okay, probably not going to be super easy to plug in your head. Okay, so you might want your equation. So 72 equals 1/2, like we already said, 200 minus x. Okay, we already went over our different options for this one. If I were to distribute, would I still get a fraction? Yeah, so that's probably not the way you want to do it, right? Okay, we probably want to go ahead and divide by 1/2, which is the same thing as multiplying by 2. Okay, so 2 times 72 is, good, 144. And I'm left with 200 minus x. Amanda, what do I do from there? Okay, subtract 200. And this is negative 56. But that's okay because it's actually equal to negative x. So what does my positive x actually equal? 56. Good. You guys agree with me when I say it's not too difficult, you just got to be careful. Okay, the ideas aren't bad, and if you find the right equation, I think you can do them. Just be careful, make sure you're getting the right equation. Okay, the last thing I want to look at is a problem that is one of the more common ones to mess up. Okay, so I just want to take a glance at this real quick. Let's make this x degrees, and I don't know, this, we'll just go easy. We'll go 100 degrees. They want you to solve for x. Somebody tell me what the problem is. I don't know the major arc. Well, I'm going to rephrase that. They don't give me the major arc. I know it. Now, what I don't want you to do, some people in the past, I haven't had it today, but they said, well, we don't know it, so it's x. It can't be x because is that angle the same as that arc? No. Okay, so it can't be x. What is it, though? Taylor? Okay, Taylor tells me that it's 260 degrees. Why? So what we're getting at is when I have two tangents, how many arcs are there total? 2. There's this one, and there's that one, right? And Taylor-Stokes, those both add to what? Because it's a circle, right? Okay, so they took 360 minus 100, and that has to be what that one equals, correct? Could they have done it the other way around? What if they gave you this as 260, could you have done the same thing to find this? Yeah. So then from there, our equation's pretty easy because I know that x is half of 260 minus 100. 260 minus 100 is 160. Half of that is 80. Okay. So I just want you to be careful. The thing I'm pointing out is they might not give you everything, but that doesn't mean you can't find it. Okay? Would it have been different if I'd have moved this and done this? Yeah. Then it wouldn't have been as easy, right? Okay. All right. So I don't have a ton of problems for you, okay, but I do know we took a lot of class to work on those notes. I did give you all evens except for one extra odd at the end.